All right, so the first thing we're going to look at is adding and subtracting radicals. What we have been doing is just simplifying. We haven't done anything else with them. So first we're going to start off with practicing adding and subtracting radicals because this is something that will come in handy. So when we add or subtract radicals, again, add or subtracting things with a square root, you can only add or subtract the coefficients. This is the number in front of your square root when the radicals or the number underneath the square root are the same. So if I look at my first example here, I have 3 square root of 5 plus 2 square root of 3. These 5 and 3 are not the same number, so I cannot add these two together at all. Treat this like you're adding like terms. So you could say 3x plus 2y plus 4x. I have square root of 5 and square root of 5. Those are the same thing. So could I add 3x plus 2y? No, but I have x's and x's, so I can add those numbers in front. 3 plus 4 is 7, so 7x plus 2y, which if you take into account the actual square roots, then you would have 7 square root of 5 plus 2 square root of 3. Okay, so again, you combine like terms. So square root of 5 and square root of 5, so 7. And if you need to rewrite it in a different order, so 3 square root of 5, put the things that are like terms next to each other first, that's fine. 3 plus 4, 7 square root of 5 plus 2 square root of 3, and then stop. There is nothing else I can do here. I cannot combine those square roots anymore. That is the most simplified this gets. Now, looking at our second example, when I am adding and subtracting radicals, I want them to be the simplest form first. That way I can find out if they have something in common. So if I look at 24, could I rewrite this, or square root of 24? I could rewrite this as a simplified radical. 24 is divisible by 6 and 4. 4 breaks down to 2 and 2. That 2 can go outside. In my experience, I'm going to leave this 6 here because that breaks down to 2 and 3, which does not simplify or exit the square root at all. So I'm just going to leave that 6 there. So I'm going to rewrite this as the square root of 6 plus 2 square root of 6. Again, combine like terms, add the numbers that are in front. So treat this like 1 square root of 6. So this turns into 3 square root of 6 because 1 plus 2 is 3. So on each one of these, you might have to go through and simplify, do a little simplification there. Try to think, oh, what would these have in common? Maybe 3. 18 and 27. These are both divisible by 3. They're also both divisible by 9. 18 divides into 9 and 2. 27 divides with 3 and 9. 9 breaks down into 3 and 3. And this 9 is going to break down into 3 and 3. So that 3 can go outside. This 2 gets boxed. This 3 gets boxed. So when you take a number outside and there's already a number outside, you multiply them together. That's negative 3 times 3 square root of 2 plus 3 times 2 square root of 3. Negative 3 times positive 3 is negative 9 square root of 2. 3 times 2 is 6. 6 square root of 3. Now, these do not have the same number under the radical sign. That means I cannot add or subtract them. I'm going to stop there. So let's do one more example of that. So I've got the square root of 3, square root of 12, and square root of 2. The 3 and 2 are not going to simplify anymore, but that 12 should be able to. So 12 is divisible by 3 and 4, and 4 is divisible by 2 and 2. So I have a pair of 2's to take outside. I'm going to rewrite this whole thing. We've got 3 square root of 3 minus, this 3 is going to stay inside. 2 goes outside with my 5. They multiply to become 10 root 3 plus 5 root 2. Now look at your like terms or your radicals that have the same number. They both have, I have 2 that have a square root of 3. So I'm going to take this as 3 minus 10. 3 minus 10 is negative root 3 plus 5 root 2. And we're done.